So welcome everyone to the HAI Weekly Research Seminar. I'm Chris Ray. I'm an associate professor at Stanford. I'm part of the SAIL Lab and CRFM, which is the Center for Research on Foundation Models. Today, I'm really thrilled to introduce Yoav Shoham. Yoav has been a professor at Stanford and is still very much on the faculty, although a professor emeritus now, was at Stanford for 28 years. The number of awards he's won are staggering. You know, it's ICHCAI Research Excellence, the Alan Newell Award, the Autonomous Agents Award, and he's been an incredible entrepreneur, founding and selling many different companies. And most recently, AI21, which will feature into this talk as I understand it. He sits on the steering committee for the AI Index, and as far as I know, is the founder part of that index. Really exciting, and chairs WeCode, a nonprofit initiative to train high-quality programmers from disadvantaged populations. Yoav's work today is quite provocative. The title is quite provocative and really exciting. So it's wonderful that he's with us today. And he's addressing the question of whether machines can understand, which is really at the core of all of AI. So I will shut up and we'll get to the main act. Yoav, so wonderful to see you and looking forward to your talk.
Hey, everybody. And Chris, thanks for the introduction. Chris, of course, is a star. So to be introduced by him is a real thrill. It is you there's material you understand well, and then you give a talk on it so others understand it. This isn't one of those cases. I've been given many talks about AI and generative AI, a term I don't like, but I've learned to pick my battles. But I thought I'd use this opportunity to speak about something I would like to understand better, no pun intended, and that what it means to understand. And my hope, ideally, this would have been in person, so we could have a really good back and forth. Let's try to compensate on what we don't do here. I really encourage people to email me. I have my email at the end, and so I can learn from all your comments. The title, of course, is pun intended. At some point I'm going to write this up, and I hope it's referred to the YouTube paper. And I hope that if anybody writes a commentary about it, they'll title the commentary "Understanding, Understanding, Understanding." So let's go. So here's things I will not speak about. I will not speak about Stable Diffusion and Midjourney and editing. And I won't speak about how it's almost cliche now to publish a paper and say this was written by AI, an article. And I won't speak about how programs can program for you or with you. And I won't speak about speech to text or text to speech. And I won't say why ChatGPT is wonderful, because you give it a few words, one sentence, and you get a whole thing. I will get back to ChatGPT later on, but from a different angle. And I definitely won't say what language models are or foundation models are, certainly not to this audience, and how to measure them, except to mention Helm, which is the most valiant effort in this really thankless task of evaluating language models. Maybe I will say one word about the excitement around language models these days. And since my focus here is more intellectual, I won't speak about the industry pickup, but it's just staggering. I'm actually here in Barcelona at some retail kind of conference, thousands of people, and you think that had other things to speak about, but all they speak about is generative AI. And but I want to speak about sort of more sort of deeper intellectual things. And here's a paper that I'm sure many of you have seen. Folks, our friends at Microsoft Research, looking at having early access to GPT-4 and evaluating it experimentally in many ways, and coming to the conclusion that it's great stuff. And so much so, title you see, Sparks of AGI. I don't like the term, but again, picking my battles. And at the end, performance strikingly close to human level performance. So a lot of excitement by rather knowledgeable, sophisticated people. At the same time, the skepticism, and you look back in time, you know, when GPT-2 came out and then 3, people said things like, so our own Percy said that GPT-2 has no clue what it's saying. And our own Andrew said that it's like somebody speaking confidently about stuff they know nothing about. And now the new thing is to take jabs at ChatGPT. And I deliberately grade these out because I'll double click on kind of some of these limitations. But just the point is that mainstream publications are focusing on it. But speaking about limitations, and I'm not speaking about anything that you all don't know, but I want to kind of put just emphasize it. So, you know, making up stuff and the fake facts and fake reasoning, fake facts or hallucination. And I'm sure you've all had fun with this, but let me share with you the fun I've had. So like everybody encountering a system that claims to know stuff, you ask it, well, what does it know about you? So I've either written or published a few books, and I asked him, so what do you know? Who wrote this, one of these books, Multi-Agent Systems? And it told me, and it's breathtaking. It's all right. The title, the authors, the date, the publisher, it even called us, me and Kevin, my co-author, prominent researchers. What's not to like here? And so I really felt really warm kind of feeling toward ChatGPT. So I was enrolled and I asked him about another book, AI Techniques in Prologue. And it gave me a similarly sort of authoritative answer, except nothing about it is right. It claimed it was written by Professor Teixeira, published by Wiley in '94, and so on. So I'd never had the pleasure of meeting this gentleman, so I looked him up, and he seemed like a fine gentleman, but this is not his area, and he certainly didn't write this. And Wiley did not publish a book on this topic. And again, near as I can tell from my searches. So that didn't feel so good. But then I realized my error. The actual book is not called AI Techniques. It's called Artificial Intelligence Techniques in Prologue. So I fed that. And it immediately saw the errors of its ways and apologized. And we're friends again. And then it continued. But now it says that a certain gentleman, Pontelli and Rossi, are the authors, published by Morgan Kaufman. And by the way, so I've noted, again, these gentlemen don't work in this area. Morgan Kaufman actually published this book. So it seemed odd that it would publish 2 competitive books. I looked up and no, they didn't publish anything else. So anyway, so you know, just made up stuff. What about reasoning? Here and you know, just a simple kind of verbal math problem that any middle schooler would do in their sleep. You got a share price on a given day, then it went up by 2%, by 2.4%, and up by 2.1, then down by 3. How much is worth now? And it's actually, I find incredibly surprising that these language models can do arithmetic. And here it did it, and it breaks it down into the stage and with explanations and all the sub-steps, which is super impressive and gives you the final share price. The problem is it's wrong. It's just this is the math wrong. And so so what is this? Is this approaching AGI, or is it what Gary Marcus called authoritative bullshit? Now, I think there's practical reasons to ask this, because there are many applications in which, if 90% of the time it's breathtakingly right, but 10% of the time it's wrong, you're dead in the water. You lose all trust, and but again, I want to think a little more sort of at the kind of intellectual side of things. What's going on here? First, note that even OpenAI kind of, I don't know if talking out of both sides of the mouth is a fair way to characterize it, but certainly hedging here. Sam saying about ChatGPT that it's a mistake to be relying on it for anything important, and a GPT-4, on one hand, very proud of it, on the other, it's flawed. Seems more impressive at first use than it does after you spend time with it. So some truth in advertising there. And the question I want to ask is not this. The practical question to ask here would be, okay, we see these limitations, how can we escape them? And in a different kind of talk, I would speak more about this. We'd speak about the brute force approach, just do more of stuff, more parameters, training data, or more RLHF or other kind of reinforcement. Put longer context windows, do retrieval method, retrieval rate, do other stuff. You can do a modest departure and do retrieval methods where at inference time, you somehow cleverly find the information that's relevant to the current query and stuff it into the context and kind of bias the answer so it's grounded in that. And there was an architecture that we were involved in called MRKL that kind of did something a little more general, and ChatGPT plugins are also that. They don't really alter the operation of the neural net, the language model, but it allows it to call on external resources. And you can take it the whole, kind of go the whole way and look at hybrid models where the neural machinery does some of the work and more standard symbolic sort of programs do the rest. And you can look at LangChain as sort of a point in this kind of spectrum, or in this kind of this landscape, and more recently AutoGPT and BabyGPT, kind of from a different point, showing you how you could do stuff that's not just a neural net doing its stuff. And these are early hints, but as I said, I will not be speaking about these. Excuse me. So since I won't be speaking, I'll just make an assertion. I say that before too long, and too long is a matter of very small number of years, we won't be speaking about language models, but AI systems, part of which will be language models. Here I'm stealing from the book of our late John McCarthy. I remember there was a talk he gave at Stanford a number of years ago, and he said something, and then somebody from the audience says, "Do you wish to argue that?" And his response is, "No, I don't wish to argue it. I just wish to assert it." So I'll just assert this one, because that's not the focus of the talk. I want to speak about these questions. When you say that the current system doesn't something, for example, doesn't understand, or maybe even more radically, systems can't in principle understand or something. What do you mean by that? And I'm going to just stop just methodically for a second, since I can't see any of you. I just want somebody to assure me that you can still hear me and see my slides. Somebody turn on the mic and say yes.
Yes.
Thank you. I'll keep going. So that's what I want to speak about. These are not new arguments that a computer isn't really doing something or can't in principle do something. So Ada Lovelace, the Countess of, I forget what, the daughter of Lord Byron, a talented kind of society lady, talented mathematician, and really a close collaborator of Charles Babbage, the inventor of arguably the first modernly architected computer. And she said that this computer, that of course wasn't built at the time, but designed and explained, said that it can do whatever we tell it to do, but it can't really think. It has no power of anticipating any truth or relation, any relations or truth. I find it just mind-boggling that in 1843, somebody could even speak about this, whether you agree with her or not is just mind-boggling. That's Lady Lovelace. Let's fast forward a little bit and focus on a specific kind of X. Can a computer or does a computer understand? So famous Chinese room argument saying, no, it doesn't. It's just faking it. This person in the room sees a sequence of Chinese characters, and just based on this rule book, responds with Chinese characters he never saw, never doesn't understand Chinese, is just going through the motions. To quote him, it understands exactly nothing. And if we look at language models in particular, echoing similar things that Percy and Andrew, I quoted them earlier, but perhaps a little more militant. So Emily Bender, and by the way, although I don't agree with everything she says, I think I really read what he writes, avidly. Speaking about language models, this would have been GPT 3.5, I think, I'm not sure, but they don't have any understanding of what they're producing. No communicative intent, no model of the world. And even more recently, Noam Chomsky in, where was it? I think it was the New York Times or the New Yorker, one of the two, wrote an opinion piece saying that ChatGPT is a lumbering statistical engine for pattern matching. This is not what the human mind does. Overall, if you look at the arguments of why computers don't really, they just follow rules, or it's not, kind of the Ada Lovelace thing, or it's not just statistics, Chomsky. Distinction between syntax and semantics, or going back to earlier days of cognitive science and logical philosophy, the notation-denotation distinction or sense and reference distinction, saying they're different and you can't understand if there's no semantics. Or maybe more practically in terms of computer systems, there's no world model. When you communicate, you have intent, kind of the natural language pragmatics. That's Emily Bender as part of her comment here. And others would say that the computer is acting in a vacuum. It's not situated in anything, not getting physical kind of feedback from the physical world. And then people speak about, well, it doesn't have beliefs, it doesn't have emotions, there's no qualia, no consciousness, so how can it understand? So what do I think? So first of all, I don't find any of these convincing, and for two reasons. First of all, I should acknowledge that I understand these intuitions, and in some sense, I share them. I have a sense that I'm not a machine. But I don't find the arguments for that convincing for two reasons. First, they're vague. You say, oh, no, you need a semantic representation. Well, what would satisfy you as being a semantic representation? If I had alongside the neural net a knowledge graph, and I I extracted the named entities, and I pointed at nodes, the knowledge graph. Do we now have semantics? Are we happy? Will any knowledge graph do? So just a vague assertion. And maybe even more less convincing is the fact that they're just assertions. Do you say we need a semantic, we need a world model? And I say not. I mean, that's the end of the conversation. There's no arguments of why that is the case and what sense it is. So I just find regardless of the conclusions, I find those arguments weak. So I don't want to speak about what I think it would take for a system to exhibit true understanding. I think what I will speak about will inform this discussion, but that's not my focus. My point is that before we say that the system is or can achieve X, we need to agree on what X is. Otherwise, we're dead in the water. And what I will claim is that we can evaluate understanding based on performance, a performative theory, without looking at the underlying mechanism that produced it. And that this performance can be observed, quantified, and we can apply rigorous criteria. So in this sense, it's sort of like a Turing test. So I don't think the Turing test is the right test for understanding, but it does share this characteristic that it's behavioral. Maybe I should call it behavioral, not performative. Well, then the question is what behavior, what performance, and which criteria to apply. And I'll just point out that we're at slide 39, and out of 47, and only now we're speaking about what I said I would be speaking about. But we'll be going a little slower now. Also, I know that they wanted me to stop after about 40 minutes, so we can have a conversation. I'll do that. So, so what is understanding? Lots of people have written about it, and the first thing you want to do is learn from them. And so first you go to the master Google and ask it, and you get a dictionary definition of it. And then you go to the true source of truth, and that's Wikipedia. And there's a little more written about that, a little more verbose. And then you go really learn it, and you go to the Stanford Encyclopedia of Philosophy, and this is actually a very long piece, a very epistemological kind of orientation. And then you want perhaps something a little more lighthearted, you ask Quora. And they say, well, teachers and educators must ask, when does a student understand something, and try to learn from that. And religion, I mean, a lot of what the Dharma is reaching through understanding. Well, what does it mean? And so it's fascinating reading, and there's a lot to learn from it. But at the end of the day, it's not clear what to do with that. How do you take that and make it operational in any sense? And so that's what I want to propose now. It won't be a final answer, but it'll be a framework for how to define understanding and measure it. So first I want to speak about some intuitions that underlie the proposal, and then the proposal itself. So in some sense, the intuition will also be just assertive. I mean, say here intuitions are driving the definitions, but they're not arbitrary. I think you look at them and you say, yes, at the end of the day, we're taking a very common sense notion, understanding, and trying to, somehow formalize it and operationalize it. So you better be faithful to the everyday use, because that's what we're trying to relate to. And I think what I'm about to say is fairly unobjectionable, which of course means you may object, and it'll be great to have a conversation. The first thing is understanding is a matter of scope. We don't just understand, we understand something, like arithmetic. You don't say, oh, the person understands. You either explicitly or implicitly say what it is that he or she understands. That's one thing, the scope. And the scope is not as simple as saying a word like arithmetic, because there are different ways of measuring depending on context. When you say a 10-year-old understands arithmetic, it means something different than an expert mathematician. And so you need to define the scope by more than just naming a word. And finally, understanding is a matter of degree. It's not like we understand or don't. There are many students that understand arithmetic, but they score differently on the exam. And so these are some of the basic intuitions that will drive the framework that I'm going to propose. And by the way, I'm mentioning arithmetic here just so we have something concrete to think about, but you really should understand it very generally. Every subject matter should have these characteristics. Understanding Buddhism, same principles apply here. So here's some of the key ideas, and then I'll actually propose what the theory might look like. First of all, you need some kind of performance modality. There's some behavior you want to observe. The question is, what is producing this behavior? And I'm going to focus on question answering. You're going to, I think, consider a system where you ask questions, you get back answers. And you could definitely consider other modalities. For example, by looking at question answering, I will not be able to deal with the question of whether my dog understands. Maybe something else like instruction following would be make that more possible. But for concreteness, I'll think about question answering. So you're going to pose question to the system. It's going to provide answers. And based on that, you'll need to decide, does the system understand? And when you evaluate that question, there are a few things, intuitions about what you want to bring to bear. First of all, the overall performance must be okay. In other words, if you're going to ask whether a student understands arithmetic, if he answered 2 out of 100 questions correctly, no matter what, you can't say that they understand arithmetic. And so there's some overall performance, a passing grade that you need to apply here. That's one kind of criterion. The other, and that's really important, is it's okay and sometimes the right thing to say, I don't know. And that's something that systems today aren't good at. And so it's okay to say, I don't know, but not to everything. So if I'm appealing to mathematics just for concreteness, but if I ask a very complicated mathematical question and the person says, I don't know, that's okay. It doesn't mean that they don't understand mathematics. They just didn't get this answer right. I remember when I was in the finals of the Math Olympiad in Israel many, many years ago, there were many questions I did not know the answer to. And still, I felt I knew mathematics at the time. That's no longer the case, but then I knew. So it's okay to say, I don't know, but not to everything. There are certain things, if you say, I don't know, you don't understand this domain. So I asked you a question of arithmetic, and I don't care how well you answer very complicated questions, but when I ask you, how much is 1 + 1, you say, I don't know, that's a problem. When you do answer other than I don't know, it's okay to make mistakes, but you can't be ridiculous. Certain answers are just so nonsensical, they display a lack of understanding. And again, 1 + 1, if you tell me it's 3, that's ridiculous. But there are other cases the ridiculous answers aren't as blatant, but you would still, and these are all judgment calls, right? What's a passing grade? What is the question to which you're not allowed to say, I don't know? And what's ridiculous is a parameter to be fed into the system. But you need to do this. And finally, you should be able to explain answers, both correct answers and incorrect answers. And here I'll just set expectations that I'll have more to say about all of these things, except for explanation. Here I have things to say, but I don't understand it as well as I'd like. And it's complicated, so I'm going to punt on that. I'll just say that you need that element. So these ideas. So now let's implement those ideas. And I think I have 2 more slides, and then I'm done with the real presentation. So what's the setting? So questions, right? So let's fix the class of questions. This is a scope. And it's not all, say, mathematics, not all the questions in arithmetic, but some set of questions. And that will define that X which you do or do not understand. And also the class, I care less what the class of answers is, because you see in a moment that some answers will be right and wrong, and but there's some class of answers. The thing that I think worth mentioning is that this Q can't be too small, can't be too large. For the issue of understanding to have meaning. If Q has 2 questions, One is how much is 2 plus 3? And another is how much does a refrigerator weigh? And that's all the questions I want to, if you need to answer. We wouldn't say, oh, he understands X. There's no X here that to be understood. It has to be some natural class that's large enough that's worth applying the term understanding to. So it can't be too small. But it's got to be some reasonable scope. It can't be, as in the Chinese room kind of example, all sentences are Chinese. This doesn't make sense. It's way too large a class because it's nobody can answer all sentences in Chinese correctly. It's a mythical rule book that underlies the example of the Chinese room argument can't exist. And so it has to be also reasonable in size. So that's the note. Now, and this is actually not key, but you can fix a distribution over the question, reflecting either the natural occurrence in what we care about, or perhaps their importance, or not, and just default to uniform, doesn't matter. So now we have a set of questions and answers. Now, let's say how good an answer is to a given question. Just let's say a scoring function between 0 and 1. And in the next slide, I'm going to tell you how we're going to use these definitions. Here are just definitions, but I'll give you intuition about each of those. So, so we have so far the set of questions and answers. We have a score of how good an answer is to a given question. And the next thing is, there'll be 3 sets we'll describe. This is a set of questions, and these are questions to which you must give an answer. You can't say, I don't know. Okay? That's the intuition. The next set is a set, I don't know. These are all the, and this is not a set of questions, it's a set of pairs, question, answer, where the answer is, I don't know. Okay, definition. Then there's the fail set. These are all these sets of, again, question, answer pairs on which you get a fail, get 0. And by the way, you've got to include the I don't know. It's okay to say I don't know, but you get a score of 0. So if I ask you whether how much is 1 plus 1, whether you tell me 3 or I don't know, you get a score of 0. And the last set, if I remember correctly, is the ridiculous set. These is a subset of the wrong answers you give that are ridiculous, not just wrong, but ridiculous. And by the way, saying I don't know is never ridiculous. It'll give you a score of 0, but it's not ridiculous. Okay, so these are the moving parts with which we can we'll set out to define what does it mean to understand something. Now, so how do we use those elements? So first of all, the passing grade. You need some min average score across all questions. So whether you take the distribution or the uniform distribution over all questions, you want the average score to be sufficiently high. Secondly, within the required set, you can't be too wrong. And again, I'm deliberately leaving it open. What is the min score? You could demand perfection, like 1, or you could demand something else. It doesn't matter right now for the conversation, but you cannot be very wrong about 1 plus 1. It also means that in the required set, you can never say, I don't know, because that's a score of 0 and it's below the min score. You can never be ridiculous. That's a key requirement. If there's something that you, the evaluator of the system, considers ridiculous and the system says that, the system does not understand. And notice that I'm focusing a lot on the sort of the negative outliers, the zeros and the lows, the min score. I don't care about the positive outliers. I don't care about the questions to which you get an amazingly good answers, because we're not trying to identify whether the system is a genius. just whether it understands something. And finally, explanations. And as I said, I'm not going to say more about it now, mostly because it's more complicated. And so I'll leave this for another time. So what did we say? You know, a performative or behavioral theory, just as in Turing test, you can observe input-output, and I limited for the sake of discussion to questions and answers. You have a scope, so you know what questions are relevant. Those define the scope. Scope can't be too small, can't be too big. And the questions better, the answers better satisfy certain properties. Overall, they can't be terrible. There's certain thing you have to answer right. It's okay to say, I don't know, but not to certain things. And you can never be ridiculous. And if you do this, it would be said is that you understand the subject matter as defined by a set of questions. And there's explanations I didn't speak about. All right, so what does it mean? Can computers understand? And like I said, in my, I think in my abstract, here I'm with Turing, and here's what he said. He didn't speak about understanding per se, but more generally about human characteristics and claimed that they could never be imitated by a machine. And he said, I can't give you this comfort. I don't believe that you can provide these lower bounds on the capabilities of machines. And I agree. I think machines can understand, but they don't yet because they are ridiculous. So that's what I had to say about understanding. I'll stop now, and I just want to emphasize again, I view this as a beginning of an exploration and would love your comments. And with this, I am going to attempt to stop screen sharing. Okay.
Fantastic. Let's give a round of applause. I don't know if you can see the little applause emojis floating up, Yoav. That was really, really wonderful. I would encourage folks right now. There is the question answer, which was linked several times in the chat, and I'll just re-put it up there to go and vote on various different questions, which we can ask Yoav while he gets a sip of coffee and we think about it. Couple things, Yoav. Thanks so much for the wonderful talk. There were a couple of themes that I saw in the chat that I thought I would kind of start our discussion off. Maybe to start in the broadest sense, since you brought up the Buddhist philosophy, and I couldn't resist. The question, what did you expect to find there? And here, why are you coming to this? What do you expect to find there? And what are the notions of understanding that you think would really move the field forward or be really interesting? And if the machines can simulate this other thing, which seems so close to understanding, does our notion of understanding matter? And I think it's something that was kind of a theme in the chat.
So several different questions folded into what you said, and I'll try to answer them in order. Coming into it, I really did not have preconceived or expectation of what to see. I just wanted to see what insight people had and what I could learn from it. I really came into it open-minded. I did have the bias of, can I pick from it anything that I can implement, either implement to make a system understand or at least to test. And increasingly, I gravitate towards evaluation of understanding. But I didn't expect anything in particular. That's the answer to that. Another question that folded, that you emphasized towards the end is, who cares? And I think that's a legitimate question. By the way, it reminds me of a conversation we had many years ago in a panel that Yuda Pro chaired at UAI actually, the issue came that issue came out with respect to causality, and I was making the point, here are things that a theory of causality really should respect if it should be worth the name. And one of the people on the panel, let's call him Adam Grove, said, who cares? If it does work for me, I don't care. And I understand this, but there's a reason we call it causality and not a refrigerator. Somehow the term causality seems to guide us here. And the question is, at what point is guidance misleading here? And you see that it seems to have practical ramifications because the people commenting on language model now refer to that term and say, oh, this isn't real. Now, I think that's proxy for saying there's some latent variable in oral understanding, and its absence is giving rise to all these horrible things we're seeing. So I think there's practical reason for it, and that also guiding me. But I also have this philosophical, epistemological interest saying, can we have a definition that's beautiful and right?
Yeah, I think I come down on the last of your points, which is I think it's just interesting. But I think there is this kind of question when you're doing things in a performative way, one not a totally operational way, which would be another piece. Kind of following up on that, there was another set of questions and themes here. There's another kinds of notions of kind of learning and understanding, and one of those is if you say, I don't know, and then you're presented with some key insight or fact, some hint, then you can imagine that you would expect if you understood and now you're given that key piece of explanation that your understanding should somehow advance. And so, there were a couple of references to old programs like DARPA's Kalo and others where they were really trying to get at this. I think that actually sponsored part of my PhD, so I'm sympathetic to that. But the piece here is, how do you think about that playing into your definition? More of a dynamic versus static kind of view of understanding. Is that out of scope, or is that, kind of a natural evolution?
First, I think it's really a legitimate question. And, I'd want to think about this more to have a definitive opinion. But my sense right now is very relevant, but not to the question of at a given snapshot, does the system understand it or not? It's relevant to can it come to understand? There are other abstractions that aren't understanding, like intelligence and maybe it understands certain things, a certain scope, and the result of the probing, the scope will grow. So I think the dynamic aspects of understanding are interesting, maybe not directly to where they're in a snapshot, but I reserve the right to reverse my opinion here.
One editorializing slightly, also because of your foundational work on agents and your kind of statements at the beginning of the talk that in the future, we imagine these current models to be embedded in larger systems that are interacting. This kind of dynamic and state change seems to be on us as well. And in the same way, just understanding how the snapshot works, understanding those interactions seems like something that, there's a lot of excitement about. So I just kind of put it out there. I think it's a really interesting thing. Do you have any thoughts there from kind of your agent days of how this might evolve and what's going on there?
I think the interaction between time and mental state is very interesting. If you take knowledge, let's just put understanding for a moment. There's my knowledge about things in time and the time of my knowledge, and they both evolve. And but that doesn't impact the theory when you project it onto a single point in time, both as the time of knowledge and the time. So, I think the dynamical aspects are really interesting. I'm not sure we need to confront it immediately to answer the question, but maybe, how it is. Sometimes proving a harder theorem is easier than proving a simple theorem. So we're thinking about it.
This is fantastic. So I'm looking now at the Q&A polls. Please feel free to put these on and vote up questions. There's a ton of different questions, but I'd love to have more votes so I can more accurately reflect all the wonderful participants. So the top right question right now is, what can be learned by measuring LLMs and how they reason about topics which were completely absent from their training data? And the example they give are states of mind and fictional scenarios. I wonder if you have any thoughts there, if you've seen any of these different kinds of hallucinations and kind of reasoning pieces. Do you think those are interesting pieces? And I think what the questioner is getting at is, its ability to grapple with things which aren't kind of, in the old terminology, extensionally written down that it's seen.
Right. So people like to speak about outer distribution sample, right? And I think that's that's a dry mathematical way to refer to, I think, deep phenomena that should be teased apart. And I think it goes back to scope. What are your expectations? What should the system be good at? And you should be clear about this. And then within that scope, you'd expect performance, and obviously you'd expect generalization from whatever training data there was, or any rules given or whatever. You'd want to see robust within scope. And then out of scope, maybe manage to extrapolate to things that have nothing to do with, what you're testing, and that, power to it. But that's bonus.
Yeah, I wonder, one maybe way to refine this, which is just biased by my own thinking recently on this topic, is, it seems like in machine learning for a long time, we've had a notion of task, which I think in some sense has been overly narrow. It's been named entity detection from Twitter, on a Tuesday. We keep narrowing it down. That was the computer science view. And the thing that I love about GPT and the rest was this incredible kind of explosion of that notion. No, there's really a general statement. So even though, I think for historical reasons, I share your sometimes misgivings about AGI, there is a sense in which we're in this taskless kind of broad environment. And so somewhere between it can do everything and Twitter on a Tuesday, in March of 2020 or whatever, there's some kind of coarser grained notion like a skill or something that somehow we expect if we mastered that skill, say arithmetic, or, the example I sometimes think about is French summarization. I clearly have to learn a little bit of French. I have to learn what makes a good summary, and maybe there are peculiarities of how the French like to summarize. So there are these composable blocks. How does that kind of composition of knowledge figure into this kind of testing? Are those individual tests, or how do you think about that?
So I think the reason we're having this conversation in the first place is that people complain that these systems don't understand. If, nobody complained about databases that they don't understand. They, and something about databases, but they do a job, and they do a job in a remarkably clear and useful way, and they can be pushed in various directions. But at the end of the day, there are these databases, these things that look like cylinders in a publication. And now, if we could, I think, legitimately speak about an LLM as a tool, really as a modern day database, going beyond NoSQL to just embedded vector DBs, and that's the new database. And it retrieves stuff. It retrieves stuff in very complicated ways, composes them, and does really interesting stuff. But that's what it is. It's a database that retrieves stuff. I think that would obviate a lot of the conversation, because you wouldn't project human-like capabilities. But then really I would expect that Microsoft would not write a paper speaking about sparks of intelligence. They'll maybe speak about sparks of a new genre of databases. But we are tempted to speak about intelligence and understanding and things like it, even emotions, if you're a New York Times reporter trying to be seduced by ChatGPT into leaving your wife. And if we do that, then we do confront the issues of, well, what do we mean by, for example, understanding? So it's more depends on us. And I think it's a losing battle, I think, to try to get the community at large, technical and non-technical, to not project these human-like characteristics on these amazing machines. And then we have to deal with it.
So you mentioned something there that I found really interesting, and have been following in kind of the New York Times, Wall Street Journal milieu of these things. You mentioned an understanding, and there's also kind of this emotional component to what you just described, right? You mentioned that ChatGPT leaving the wife story. The one that always stuck with me, which was surprising, was the stories about Replica, the service where people had engaged very deeply with their AI bots, and when they believed there was a kind of a wipe, and then they were mourning those losses and so on. and this ability of humans to make a connection. How does that kind of connection or emotional intelligence relate to understanding if we're projecting this vast kind of human experience onto these bots? Is that another talk that we should get you back for in 6 months, or is that completely out of scope and just humans being humans and falling in love with pets and other things?
Right. So whenever we speak about mental state, it's simpler to speak about informational mental states like knowledge and belief and understanding, and as opposed to affective or emotional mental states like belief, desire, intention, all of that, because that's even more complicated. And so as a scientist, I'd like to look at one of the simplest things I don't understand it before going to more complicated things. But it may be thrust upon us sooner than that. And certainly the temptation to ELIZA these systems is so powerful that if nothing else, we need to engage in public education, if not actual scientific research about what this means.
Well, in the same way, how did you draw that distinction? Because it's an interesting one to me. You say, okay, I don't understand understanding, which, arguably has been the quest of, large swath of humanity are writing for thousands of years. Then there's the kind of emotional intelligence, which is also, as you say, kind of more complicated. Why not educate the public and say, these things don't understand, kind of to your database kind of view? Or do you think that horse is out of the barn? And in fact, why draw the line in one place rather than the other? Or where should we draw the line if you could redraw it in terms of how we think about these things?
Right. I didn't mean to imply that we should educate the public about emotions and not educate them about understanding. I was trying to say, as a scientist, the latter are easier for me to understand than the former, the emotions. But to the extent that they're misleading, we should set the right expectations with the public about both.
Let me go back to the list. This is wonderful. I think there's a question which I think, given your experience both in the research side, kind of as meeting in this space, and quite practically building these models and playing with them. What do you think are the observable and measurable limitations of foundation models and LLMs that are most obvious to you? You've had some things where, as you mentioned, there was a snapshot at GPT-3 and 3.5 and 4 that have kind of different qualitative behaviors. But what are those limitations that are most on your mind, and that will be measurable in some ways?
I don't have a good answer. I pointed to specific sort of failure modes of hallucination and poor reasoning. I thought those loom largest for me. They're both, if you want to be scientific about it, ought to be defined better than they are right now, but intuitively we sort of understand it. But I think if I were to put on my practical hat, the thing I most warn people about is we have these engines that are very powerful, but there's two things to know about them. First of all, they're statistical machines, and you won't always get something you like, and you need to work around that. Working around it could be putting guardrails, could be running statistical multiple times to iron out the variance, and all kinds of stuff you could do. But it also means that you should put on a product hat on, and so people speak about product market fit, right? About whether a product is at a point where it actually meets a need in the marketplace. I speak also about product algo fit. So you have this algorithm that's complicated with a big stochastic element, and it has limitations. And as much as you try to minimize them, it's not an algorithm that you'll be able to prove, soundness and completeness for. So you need to decide your experience, whether it's a service or typically an application, to compensate for these limitations. That's the product algo fit. and in particular, be very clear about the division of labor between person and machine, bearing in mind the limitation and the tolerance in this application domain for failure. So for example, take long form generation, which I think is in the textual kind of Gen AI world is exciting people. You write, a couple of words and you get a whole blog post, or, at Stanford, a whole essay that you hand into your professor. And there's something very exciting about it. First of all, it's kind of miraculous to see it come together and be this value exchange. It's something for nothing, or a lot for a little. So that's wonderful. The thing is, maybe it's okay when you hand in a term paper. It's not okay if you're writing a memo to investors or to your boss or your client. There, if you get it, wrong, if you're ridiculous or just wrong, 5% of the time you've lost all trust, and so you really have to work around it. And so, for example, and now this is not advertising for our stuff, but we have this application called WordTune that helps you write. And we deliberately did not do long form generation, but limited how much generative stuff is added. So it's bite-sized and you could see it. You have the provenance, that's the database term, right? Provenance, where it came from, and you can eyeball it and decide to accept or not. So that's an example of striving for product algo fit.
This is really fascinating. And I think there's one question I'm kind of scanning through the list that kind of is on this product kind of algo fit. And it was very concrete. It says, does it make sense to use LLMs or foundation models as tutors in the classrooms, given they cannot understand? And the reason I like this question so much is it kind of touches on what you were just describing. Even if this model is some kind of surfeit, some fake of understanding at one point in time, the human can still have, you said, the value exchange. They can actually get this kind of back and forth with it. So on the specific topic of tutoring, what are your feelings on this? Is this something that we're missing the boat by not being more aggressive on? Are we being perhaps too aggressive and that 5% violation is something that they can't catch? How do you think humans will adapt to this in kind of an educational context?
I actually missed some of the words at the beginning, but I won't ask you to repeat the question. But I'll answer it as I understand it. I'm actually very bullish on applications in education for language technology. I think that's characteristic where there's a certain tolerance for failure, and the cost of failure is overshadowed by the value brought by the successful cases. And by the way, the tutoring systems, they can do. I think the opportunities for embedding language technology in the classroom have just been scratched. So we speak about understanding weak points and providing contextually relevant material and so on. We should really think about language models game theoretically, and I'll tell you what I mean by that. We typically think of a language model as this passive assistant, a tool for us to use, and whose goals are to maximize our utility function. I'm a student, is there to help me learn better. And often that's good. In fact, that's exactly the value of work. But we can imagine language models as testers. Now in the era where the famous Atlantic piece, the college essay is dead, from when was it? Not quite a year ago. But that's fine. So people hand in essays, can you use a language model to ask them questions and assess? Because why did we want them to write essays in the first place? To see if they know stuff, if they understand stuff, again, this understanding term, and if they can express themselves well. So now if language model does all of that, the writing of the essay won't test it, but now language model could actually perhaps test those things proactively. And now think about it as a mechanism design. These are goals of the educator, not the goal of the student interacting. I think the opportunities here are really nice.
Yeah, fantastic. I happen to agree. I think it's a wonderful area. I believe we are now at time. I'm seeing some flickers around here. So if folks could, again, use their clapping emojis and all the rest to thank Yoav. I mean, what a wonderful talk and discussion. Such an honor to participate with that. And I hope to get to see you again in person really soon, Yoav. Thanks so much.
Looking forward. Thanks for having me. And really, you all, please do write me. I want to learn and understand understanding better.
See you. Bye-bye.